We're live, and let's continue solving an array sorted in ascending order with distinct values. Prior to being passed to a function, nums is possibly left rotated at unknown index k, such that the resultant array, for example, from 0 to 7 might be rotated by 3. So we have here first 3 value, 4, 5, 6, 7, and then 0, 1, and 2. So we are given an array nums after the possible rotation and integer target. We have to return the integer target if it is in our array, or -1 if we cannot find it. So how can we actually check this value? So let's find out what options we can have. So first option, we can have like all sorted values. Then we can, for example, have left rotated values. So it can be like 4, 5, 1, 2, 3. Then we have another option. We can have 1, 4, 3, or so can be left rotated like 2, 3, 4, 5, and 1. So what does it mean? So we have like these 3 options. And if we want to find a 2 and we find some middle element and we see that it's like correctly positioned, so it means that that we move our right pointer here. If we want to find 2, but we see situation with with 4 is greater than mid, so left is greater than mid, and our element somewhere our element is less than left, then we should move left pointer. If in case, so left pointer. If in this case we are looking for let's say let's say that we are looking for 2. So in this case we just already found this 2. Or if we're looking for 3, then we just move our right pointer here. So what does it mean? So it means that we are moving our right pointer when our element on the left is less than the current, and also the target element somewhere here. If we're looking for the element and we can check that we want to move right only if in the case where the right side is greater and we are moving. Okay, so let's try to implement this. So we have our I that let's say -1, and also we have j that nums lengths, and then while j minus I is greater than 0. And here we have our mid element. So it would be nums. Nums j minus I divided by 2 plus I. And if nums m equal to target, for example here 0, 1, 2, 3, 4, we just return m. Otherwise we can check if nums m is greater than nums I and target is less than nums m, it means that we should move our right pointer to mid. Else we are moving our left pointer to mid. And in this case we can return if we can return if I equals to -1, then we check nums j equals to target, and if it's equals, then we return j. Otherwise we can check nums I equal to target, then return I, otherwise we return -1. So let's check. Let's say not equals, or no, equals. If it not equals, let's say like this. So if it not equals, yeah, I think like this. So if is not equal, then we check if j is equal to target, so we return j. Yes. Otherwise we return -1. So it first thing. Then we check this one with target. If yes, then we return this. Otherwise -1. And here maybe I plus 1. Okay, so let's check with this example. We have 4, 5, we're looking for 0. So first we take 7 and we see that 7 is greater than 4, but target and yeah, so we need to check here, and nums is greater and target is greater than nums I plus 1. So it means that it's somewhere in between. It's greater or equal. Maybe something like this. Greater or equal. And also we should check if I is I plus 1 is not equal to nums length. Okay, so let's check. I think this one is not correct. So we take our mid index and we check with, like, first we take 7 and it's not comparing. Then we check that, okay, we have nums m, so it's 7 is greater than the last element, yes. And we check that num 7 is greater than target or equal. Yeah, probably greater, right? Because here we check already. So we check that is greater than target. So 7 is greater than 0. And target is greater or equals to 4. No. So if no, then we have this situation where we move our I to m. Then we check again. From 7 we check like middle. Middle would be probably this one. So we take this one, and 1 is not equal. Then we check like 1 is greater than this one. Okay. 1 is not greater, so we are moving this one here. Then we have 2. Time limit, yeah, I think here. Yeah, so the problem is to identify actually when we should move, because here when we're on 7, we actually should move to maybe +1. Let me serve 0. Let's -1. And then here we can check if j otherwise nums. Yeah, just like this. Time limit. We have here like -1. Here +1. Okay, so 3 we found, but here we cannot find 0. So okay, so here we start with 0 and the last element. So the last element here, it would be 6, right? So 6 divided by 2 would be 3. So we take 0, 1, 2, 3. So we check 7 and equal. 7 is greater. Here it should be not +1 on the side. Okay, let's run 5, 1, and 3. So we have such situation where we have 5, 1, and 3, and we want to find 5. So we have this one. Then we calculate the mean, so it would be like 2 divided by 2 would be 1, so 1. And yeah, and here we see that 1 can also maybe check with like nums I equal to target, return I, and also if nums j equal to target, we just return j, and this should work. But could be not for all cases. Yeah, for example here when we have 2, 5, we need to move, yeah, so here we identify first that this one is not equal, so 2 is not greater than 5, but we still need to move. So it should be maybe not and, it should be like or, Yeah, so it should be or target M. Yeah, if target M is less, so target M is less than M, yeah, I think this one should be something like this. It should be or if this one and no, if like otherwise. So if this value is greater and target is less than nums M, because target here is 2, and we have values that is less, then yeah, we should go left. Use this use case. Yeah, and here yeah, I think the same situation. So we have 2 yeah, so and here like all should be or target is greater than nums j. Okay, so now it works, but we see a lot of wrong answers. Let's check what we have here. Here we have just simple while loop. What we have here, yeah, it's also the same with like a lot of if statements here. Here I think more simpler, right? Something like this. I think yeah, the same that we have, just with multiple ifs blocks. We just put it everything in one. With all different situations. And do we have editorial access? No. Okay. Yeah, kind of the same as other things, and so we solve it. And that's it for today.